Hello, welcome. Let's try to solve another Leetcode problem. 1530, number of good leaf nodes pairs. So for this problem, we are given the root of a boundary tree and it is a distance. So a pair of two different leaf nodes of a boundary tree is said to be good if the length of the shortest path between them is less than or equal to the distance. So we're going to return the number of good leaf nodes pairs in the tree. The description is not so hard. Let's just analyze an example. So in this example, in the first example, we have this kind of a tree structure, and the distance is going to be 3, and we're going to check the leaf node. It's going to be this node 4 and this node 3. So for this node 4 and 3, the distance is going to be 3. It meets the condition, and there's only one pair, so we're going to return 1. And for the second example, we should know we're going to have two pairs. Let me just use another color. So we have a pair of 4 and 5, and we have a pair of 6 and 7, because for 4 and 5, the shortest distance is 4 to 5, it's going to be 2. And for 6, 7, it's going to be 6, 3, and 7, so the shortest distance is going to be 2. So there are two pairs. So if we choose another pair, maybe 4 and 6, so the distance is going to be 2 plus 2, it's going to be 4, but it didn't meet the condition, so the distance should be less than or equal to the distance. So it's going to be 2. But exactly how can we solve such kind of problem? I mean, for such kind of problem, definitely we're going to analyze according to the tree structure. Let's just use the second example. Maybe it's easier to analyze. So in the second example, we are starting from this root node. Let me use the red color. So we are starting from this root node. And then we're going to go to the left and the right, and for each of the child node, we go to its left and right. Now, the condition is that we always want to choose we always want to enumerate all the distance from the left and the right. So if we can enumerate the distance from the left and we can enumerate the distance from the right, and then we can just have a check from the root node from this node 1. So if the distance is less than equal to 3, so we're going to count it. And for each of the node, we're going to repeat the same calculation. So for this node 1, we're going to check all the distances. So it's going to be 2 plus 2, and it's going to be 4. This 2 plus 2, and it's going to be 4. And this 2 plus 2 going to be 4. And this 2 plus 2 going to be 4. So all the distance is going to be 4. It didn't meet the condition. And then we're going to check this node 2. So the distance is going to be 1 plus 1 is going to be 2, so we're going to count it as 1. And for this node 3, 1 and 1, we're going to count it as 1. So there are two pairs. But do we need to use the brute force, like from the root node to the left child and the right child? Actually, we don't need to do that. We can just use the post-order traversal. So the post-order traversal idea is that we're going to first check the child node. So for this node and 5, we're going to first check this node at 4 and 5, and then we're going to return the final result to this node 2. And similarly, we're going to check the node 6 and 7 first, and then we're going to return the final result to this node 3. And then for this node 1, we just need to check the node 2 and node 3 to get the final result. But what going to be the idea to solve the problem? Because we need to enumerate all the possible answers, so maybe for the final return, we're going to return an array, because inside an array, we can enumerate all the possible values. So for this node 2, what if we can return some distance? Maybe we can return a distance inside the array, and it's going to be 2 and 2. This 2 and 2 means the distance from node 1 to 4, the distance is 2, 1 to 5, the distance is 2. Similarly, for this node 3, if we can return some distance like 2 and 2, so for this node 3, the distance 2 and 2 means 1, 3, 6, 1, 3, 7, it has two distance. Then we just need to enumerate, just use a nested loop to check the two arrays. So 2 plus 2, this 2 plus this 2, this 2 plus this 2, and this 2 plus this 2. But currently for this node 1, we don't have any answer because the distance is 4. It is more than 3. But while we are checking node 1, it is like that. But what about we get some return from this node 4? So for this node 4, what if we give a return of 1, and similarly for this node 5. Yeah. So this 1 means for this node 4 to this node 2, there is a distance of 1. Yeah, so we're gonna have a 1 inside, another 1 inside. And similarly for node 6 and 7, we're gonna have a subarray. We're gonna have an array. Inside array, it's gonna be 1 and 1. So for this 4 and 5, we just need to enumerate 1 plus 1, it's gonna be 2. So this distance 2 gonna be how many? Yeah, from this distance 2, we can count how many pairs. So it is 1 pair, and this is another pair. Yeah, so actually this is the idea. But what if yeah, but what if we don't have so for example, we only have node 1, 2, 4, and 5. We don't have the right side. So can we get any pairs? No, we cannot, because we can only have 1 pair, but it's not 2. For this node 4 and 5, we have a result of 1, 1, and 1. Yeah, so it is it is a pair. This 1 plus this 1, it is a 2. It is less than the distance 3. We have 1 pair. Yeah, but for this node 1, currently for this node 1, at the left side we get an array. It is 2 and 2. But what about the right side? Because at the right side, the not dot right side, there's nothing. So what are we gonna do? So if there's nothing, we're gonna get an empty array. So now we're gonna check 2 inside the empty array, because there's nothing inside the empty array. Definitely we don't need to check. Yeah, so this is why if there's a leaf node, we're gonna return a 1. If there's nothing, we're gonna return an empty array. And then we just need to use the post-order traversal to solve the problem. Yeah, I think now it should be clear. Because the post-order traversal, we just need to loop through each of the node only once. So the I think I'm gonna analyze the time complexity after solving the problem, because that's gonna be easy to understand the time complexity according to the code. Yeah. Yeah. Now let's just write the post-order traversal DFS. So I'm gonna check the node. If not node, I'm gonna return an empty array. So this case is for the node 1. If the right side is nothing, I'm gonna return an empty array. And if it is a leaf node, if not dot left, and not dot right, yeah, so I'm gonna return a 1. So this means I'm gonna have a distance of 1. This is my beginning. If this node is a leaf node, I'm gonna have a 1. Yeah, I'm gonna prepare such. I'm gonna have such kind of design. If I don't have such kind of design, how can I solve the problem? Yeah, because if I give a 1, array 1 and array 1 for this node 2, definitely I can use a nested loop to check all the possible distance, because this 1 plus this 1 is gonna be 2, and this 2 gonna be this this distance 2 gonna be used for this node 2. Yeah. Now I can check the left and right. It's gonna be the not DFS not dot left, and DFS not dot right. Yeah, so for this left and right, actually I'm gonna return a subarray. This means for this node 4, if I'm checking this node 4, I'm gonna give a return. It means DFS not dot left, and finally I'm gonna return an array, and this array gonna be 1, and for node 4, and this is gonna be node 5. Yeah. Now I'm gonna check the result for this node 2, but how can I check that? I can directly use this L and R. Yeah. So I'm gonna use for A inside L and for B inside R. I'm gonna check the distance. If A plus B less than or equal to the distance. So this means my global variable, I'm gonna prepare a self.result gonna plus equal to 1. Yeah. Now I'm gonna return the final result. So the final result is gonna be n plus 1 for n in L plus R. Yeah, so why? This is really important for the final return. Yeah, because if this is a 1, this is a array 1 for node 4, and this is a array 1 inside array 1 for node 5. So what about for this node 2? Yeah, so for this node 2, it's the parent. So the parent would collect all the possible distance. So this is 1, this is 1. If I have a parent 2, so this means for 2's parent, I'm gonna have a distance of 2 and 2. So this is why I need to use L plus R. So 1 plus 1 inside array is gonna be 1, 1. But I need to update the distance because the distance is gonna be longer for the next node 1. So while I'm gonna record the node 2, so the distance is gonna be updated to 2 and 2. So this is 1 and 1. 1 plus 1, and inside I'm gonna update it plus 1. So each of the value 1 plus 1, and this 1 plus 1 is gonna be 2 and 2. Yeah, I just need to get all the possible distance inside the array for this node 2. Yeah, and similarly for this node 3. And while I'm checking this node 1, yeah, I just need to use this kind of a nested loop to check all the possible distance. If it meets the condition, I'm gonna update the final result. Yeah. Now we can just return it. So I'm gonna prepare a final global variable self.result. I'm gonna run the DFS. It's gonna be the root node, and finally I'm gonna return the self.result. Yeah. Now let me just run it to check. As you can see, it works. Now let me just submit it. As you can see, it works. And I think the speed is okay. It's like 0.1 seconds. Now let's analyze the time complexity. For the DFS part, it's going to be O(n). N is the number of nodes. It is 2 to the power of 10. Let me use another color. Yeah, it's going to be 2 to the power of 10, the number of nodes. And here we have a nested loop. But this nested loop is not n squared. Otherwise, it's going to be 2 to the power of 30. It's going to be a really big number we cannot pass. But actually, this nested loop is not n squared. It is O(n). Yeah, so the time complexity is going to be 2 to the power of 20, not 2 to the power of 30. Why? Let me analyze it. Yeah, because if this is whether if it is a balanced tree or not, but definitely we're going to analyze it according to a balanced binary tree, and that's going to be the maximum time complexity. If it is a balanced binary tree, so we're going to check this L and this R. Yeah. And for this L and this R, we're going to check how many possible cases. So it's going to be something like yeah, let me just think about it. It's going to be something like 1 plus 2 to the power 1 over 2 to the power and plus yeah, let me just analyze it. Yeah, we need to know how many nodes at the left side and how many nodes at the right side. Yeah, so it's going to be something like 1 plus 1 over 2 plus 1 over 4 plus 1 over 8. Yeah, because it is dependent on the depth of the tree. It's going to be something like that. This, and this one gonna be something times n. And for this value, it's going to be n times 2. Yeah, so the time complexity is going to be O(n). And O(n) times O(n) is going to be O(n) squared. I think it's going to be 2 to the power of 20 instead of 2 to the power of 30. Otherwise, we cannot pass. Yeah, even though maybe. Yeah, so this means for the first one we're gonna have n, but yeah, we need to use n squared. I think it is n squared. So n squared times 1 plus 1 over 2, and 1 divided by 4 and 1 divided by 8. So the final time complexity is gonna still be n squared times 2 to the power of 10. It's gonna be a big number. Yeah. Yeah, it's going to be a big number, but I don't know why this problem can pass. definitely it's going to be n cubic for the problem. Yeah, but normally we can reduce the problem to 2 to the power of 10. We can reduce the time complexity to 2 to the power of 10 times d squared. So d gonna be the distance. So for the nested loop, the longest distance is gonna be 10. So 2 to the power of 10 times 10 to the power of 2, it's gonna be a small number. It's gonna be 10 to the power of 5. So we can reduce the time complexity to 10 to the power of 5. But how can we reduce that? Yeah, that is dependent on the distance. Yeah. So from here, we can put the final return only within the distance, because for the left part or the right part, if it is more than the distance, there's no meaning to compare. So we're gonna just need to add a condition. So if n plus 1 less than or equal to the distance, we're gonna put it inside the final return. Otherwise, we don't need it. Now let me just run it and submit it. Yeah, now as you can see, it is much faster than before, because I think from here we reduced the time complexity to 2 to the power of 10 times 10 squared. Yeah, because for here, inside of this array, definitely we only put the possible distances, which is less than and equal to 10 inside of the subarray. Otherwise, it's going to be much longer for the binary tree. Now the distance would be much shorter. Yeah, if it is much shorter, so inside of the subarray, it's going to be not so many values. Yeah, I think the time complexity is a little bit difficult to analyze for such kind of problem, but definitely the key idea is that we're going to use post-order traversal to solve the problem. Thank you for watching. See you next time.